need to know x cubed plus x minus 2 equals 8. You need to figure out what that is. 2. So in these problems, if they give you anything worse than 8, you might not be able to figure out the answer, right? But you should expect the number is small enough that you can just compute in your head and figure out what it is kind of at a glance. The other way to do it would be to put this function in your calculator and put the function 8 in your calculator and see where they intersect. You understand what I'm saying? That'd be the other option. It's too complicated. But I noticed they've been giving fairly straightforward ones, it's like 1 or 2 or 0 or something. You can kind of figure it out just by staring at it. So Lee has said the answer is 2. I must agree. 2 cubed is 8. Plus 2 minus 2 is still 8. So x equals 2 is what we're looking for.
Wait, how did he get to?
He guessed. He looked at it and said 2 seems reasonable. If you just check the first few integers, -1, -2, 0, 1, 2, you know.
Okay.
You should anticipate the problem should work out nicely for these. They do not actually expect you to find this in some algebraic way.
So the derivative of f(x) or inverse of f(x) equals 1 over the derivative of f(x).
Yes, this relates only to derivatives. This is not true. F inverse of x is not 1 over f of x. That's not true. It's not. This is not what that symbol means. It means inverse. And this relationship, even if this were to mean inverse, which it does, that relationship is not true.
It has to be a y.
No, I'm just saying that. Let me ask you a question. What's the inverse of x cubed? What's the inverse of x cubed? What's the inverse function of x cubed? No. Cube root of x. If you call that the original, then this one is its inverse. Okay? Would you say that f inverse is equal to 1 over f? That's not true. The cube root of x is certainly not 1 over x cubed. That's just false, right? It's not just false for this one, it's false for all of them, right? This is never true. It only happens to be that in the case of the slopes of these things, that the relationship between the slopes is 1 over the slope, right? At a particular location, right? It's a rare instance where this notation of inverse actually comes out to be something like 1 over the original.
So 1 over the derivative of f of 2?
Yeah, f prime 2. Yeah.
So that problem right there is saying to me the entire set is inverse of the derivative inverse of the derivative is an inverse function that 8 is represented as an x rather than y. I mean y for the.
Well, this is the input for f inverse. But if it's the input for f inverse, that means it is the output. It's a y value as regards the original, right? Because inverses switch up inputs and outputs is the main idea.
So that 8 is a y value.
For f. It certainly is an x in a sense for f inverse, but the reason they use the y value, they use a y naught here, is because that's in relation to the original function. It is the y value from the original function. That's why we're setting it equal to 8 here. It is an output from the original. And that's how you find the x that you need to put into the expression.
So 1 over inverse x function x equals to the inverse function derivative 8 should equal to each other.
Yeah. And only because they're slopes. Only because they are slopes. It's not true just for function values. So you now need to find f prime and plug in 2 and then flip that value. So f prime is pretty straightforward, just a power rule. So you get 3x squared plus 1. So now you plug in the number 2. You get 3 times 2 squared plus 1. So that's 13. Now you know the answer is 1 over 13. That's our answer. Okay.
That's something that would be on your test. That's
It is on your test.
I mean that level of difficulty is not going to be.
Right. Yep.
What? Do another one.
Another one like that?
Yeah. Let
me see if I can get it without writing it down.
Let's do it, Season. 8. Oh, I was got a graph or something.
Graph?
So this one actually has you compute the inverse. So any ones that don't, number 6. That was the only one that doesn't have you compute the inverse.
You just hit similar exercise.
Ah, good point.
Oh yeah.
There you go, Cecil. Knock it out.
Okay, so we write out as 3x cubed plus 1.
Okay.
And then we're gonna plug in at -7, so that's
Oh, slow down. Hold on. Let me write it. We say 3x squared plus 1.
yep.
All right. 3x squared plus 1. That's the derivative of the original function.
Now we're gonna plug that in.
What are you plugging in?
-7.
No, careful. That's going into the inverse. So inside the original, you need something else. You can't put the -7 in here. -7 is the y value from the original. So you need to set f of x, the original,
Okay.
x cubed plus x minus 9 equal to -7. You gotta figure out what x makes that happen. That's the x that goes right there. What x makes that happen? Lee, did you figure it out?
Oh, forget about that step. Okay, so that's
1. 1 makes this true. So x equals 1. Now we know what goes in the formula, a 1.
So I take the equation equal to that number that you're given, and then
I put that one into the formula.
Yep.
That's right. Not the -7.
Can't see it all.
Oh, now it's too dark for you.
No,
Gotcha.
it
Oh.
can't. Is that formula set up as 3, 3, 1?
3 1 squared, because it was 3x squared plus 1.
That's plus 1 at the end?
Yeah, because the derivative is 3x squared plus 1. And the x value 1 is a 1. Does it give you? What's that?
I don't know where you got the plus 1.
Because x cubed plus x, that x turns into a 1 when you take its derivative.
Oh, we took the derivative is the
What's that there?
Okay, we took the okay.
Right, that's why I was saying the relationship here is only between derivatives, only between slopes of these functions, not between the functions themselves. Oh, we're going to get up early today. You guys are Justin, did Baker give up, or is he just not here tonight? Did you say? Did he say anything?
How much do you want?
Britain.
And Pierce's gonna be open until midnight.
I think so.
just finish it off already.
I think so.